Give me just a
Give me
second.
just a second.
Uh, uh, Now we are live, I
Now
guess.
we are live, I guess.
We are live.
We
Koushik,
are
you
live.
can start.
You can start.
Yeah, okay. Yeah. So, guys, this is Python World Community's first community discussion, first tutorial, you can say. And today we will discuss about the threading techniques, lock, semaphore, mutex, and how to deal with them, how to write a good Python script on multi-threading and threading objects. So, uh, my voice is audible, guys, right? Yeah. Okay. So see, first, if you really need to go into multi-threading, before that you need to understand how operating system behaves, or how to deal with it. Okay, because even if it's a Python or C++ or Java, they are simply just a program. Okay. So that is why what happened, those programs will operate on a particular operating system and execute your program. So it's like nothing like a box inside a box. Okay, so you need to understand the top object, means the operating system here. So what is the process according to operating system? It's nothing but just a job, or a stuff it need to be done for the from the given by the user. Let's say the user asks to open a file, or write something. That is a process. Operating system need to be done. The kernel will respond according to the a given task, whether the file is readable, whether there is an error. Many stuffs are there, and in order to handle all this execution, there is a concept called queue. Means, guys, let's think like that. You went to a pizza shop, and at there you are asking for a pizza, but there are a lot of people like you who went there for pizzas, right? There will be a queue, and after one person to be served, the pizza owner can serve the next one. Like this one, it's like sequential manner. Operating system works like that. No matter how much Microsoft or other BSD licensed products, like our Darwin is our Mac. They said ki all these operating systems are multitasking, but no. In practically speaking, every operating system is basically follow a sequential manner. There is a small time lapse, small time gap between two executions. One task completed, and just after the next task gets completed, both of the tasks cannot run in a 100% parallel manner. No, there is a gap. Now our modern days technology's aim is to reduce the gap as much as possible, but it cannot be zero. So it's like there cannot be a 100% parallel lines. It is a it that those two lines will intercept each other at some point. I'm talking about the lines, that means those process will finish one after another. So this is how operating system responds. Okay, now in order to deliver all this, in order to execute all this, they have the queues. There's a concept called queue. Now what is a queue is nothing but just like a simple queue we face our daily life. We went to a shop, we have a queue. We went to buy a phone, we have a queue. Anything similar like that. There are three kind of queues. First is a job queue. Job queue means those processes which are which are prioritized by the kernel dispatcher juggle. There is a thing in kernel called dispatcher juggle. That dispatcher juggle always finds out which task or which process is going to is can be prioritized. Uh, Hello. Oh yeah, my face. Okay. Uh, is it is it fine? Is it fine, guys? Yeah. Okay. Nice. See, thing is, as for now, what I was talking about. Sorry, I just I never have any chat like that. So so dispatcher juggle. So what is dispatcher juggle? Dispatcher juggle mainly shows off what job or what process is basically most prioritized for the kernel. Means what process is going to take more time, what process is going to take less time. You see, there is a system level process that is highly prioritized. If there is a user level process, which is a level 5 process, we say in our in mostly in technological area, those are less prioritized. So dispatcher juggle, what dispatcher juggle like do, it simply put a number or a weightage on top of the on top of that process. So the process can be understand by the queue or queue executioner that this process is going to finish like this or that. So threading is almost a similar kind of concept like that. Okay, threading is the way to create those processes and push them to the ready queue or job queue. Now, the ready queue is those processes which are system level process need to be executed right now without any interval. If there is a lock, release it. Kernel will release that lock without any hesitation. So those kind of processes are put into the ready queue with higher priority. Job queue is those processes are in the waiting list. They will be executed in the next. And there is another queue which is called the wait list. Wait list means these jobs are less prioritized. When OS find out a suitable time, at that moment, OS will push one job sequentially from waitlist into the ready queue. So like this, the whole OS execution happens. Similarly for threading, this kind of stuff happen similarly for threading also. Like in threading, we have the concept of queue. In threading, we have the concept of dispatcher juggle. We have the concept of semaphore, mutex, and then lock. Obviously lock. So why in Python threading mostly used? In Python, threading mostly used to release the coding, release the pressure from a particular GIL object. Now, when we talk about threading, we have to get into the Python GIL, which is the most irritating stuff in Python. Most irritating, why I said, whenever we run a process, even if a print hello world, it has acquire a lock on GIL. GIL is nothing, the Python interpreter, global interpreter lock. So when there is when a GIL object acquires something or acquired a lock, at that moment there is nothing Python interpreter can do but to execute the process. Hello. Okay, so but to execute that particular process. So that GIL interpreter lock we cannot avoid. So by any means, program will execute in a sequential manner. What maximum can we do? If anyone asks you guys in any interview, can we do multiprocessing or parallel processing using threading? practically speaking, if the question is getting asked from a good interview or good person who really have that knowledge, your answer should be no. There is no concept called parallelism in or parallel execution in computer science. No, that cannot be achieved, that cannot be done. What we can do, that this is called semi parallel boosting. There is a difference between parallel execution and semi parallel boosting. In parallel execution, what we do there, both of the object can execute, or sorry, both of the process can execute without any dependency, no matter what, with 100% parallel manner. But that eventually is not possible, because the main executioner or the main dispatcher juggle, that cannot spawn more than one object at a time. So even if you demand that your process is a pure parallel process, it's not. Now, today I will mostly talk about the theory. Tomorrow, and also some practical, but tomorrow I will go into the hands-on morely. So what should we do next is trying to understand more into threading. Okay, so I'm sharing my screen. Hold on. Okay, so tell me if you guys see my screen. For anyone, if you guys are new in Python, okay, buy a laptop which is basically is a Linux laptop, pre-built Linux laptop, or use Linux, because that is the best operating system for any developer. Okay, and I'm gonna use for today's lesson. Hold on. Okay, now best way to learn any module is like this. Simply bring up your interpreter and import the module. Okay, and then you need to understand, or you need to play with the module. You need to find out what Python is offering first. So in order to do that, simply do like this. Okay, so this is what you should do. Bring up all the attributes, all the objects or methods or whatever things are there into this manner, put it in a notepad. Okay, now go through all the methods. First, go through a basic concept of threading, like what I tell you now. Next, go through all the methods or all the objects that Python is actually offering. Okay, so first, now we have a decent understanding that how Python interpreter or threading objects and those stuffs actually do. Hold on. Why? Okay, sorry guys. Okay, yeah. So now, why should we use first questions? If it doesn't give us any parallel behavior, why should we use threading either at all? Because of one stuff, speed. Python is a slowpoke. Python is a slowpoke. Please, whoever listening to me, don't get angry, but this is a fact. So it follows a dim or drastic threading technology. What is a drastic threading technology? Every process, every execution, every line interpretation is basically a interloop thread. Now, what is an interloop thread? That is very interesting stuff. Interloop thread, when the interpreter creates the thread by on itself, and it doesn't require any kind of any kind of user intervention or third party intervention, then it's called an interleaf loop. Now people might ask, hey, there is an I can create a thread externally. Yes, but that is your intervention. Python interpreter can create threads on demand because it requires that part. Now, when you write print hello world, your main thread create a child thread, and that child thread executed returns a response to the main thread, and main thread returns a response to your main screen. So this is how the whole process happened. But it is fast. If you use thread, single threaded process, super damn fast. But multi-threading is not actually a multi-threading. You can divide your program or the whole task into smaller chunks, and those chunks can start or at least keep on spawning on a particular time interval or on some conditions, on some events. Those condition, events, lock objects, those things we will try to discover in Python in this threading module. First is barrier. The biggest stuff is barrier. Now, what is the barrier? See, guys, you really can control the behavior of a program if you really control the behavior, how it executes. I'm not telling like a behavior of a program in that way, but the way it execution, the runtime execution, if you really can control it, that would be a biggest benefit to your program. Okay, let's say I'm giving you an incident. Let's say you are running up you are given a task to scrap 5 pages from a website. Okay, let's say the link of the website is, let's say it's https and then colon some shit some page slash one. One is your first page, two is your second, three is your third page, like this. So it takes about 20 seconds to scrap one page. Okay, so in and around 3 pages will take, if we go with sequential manner, 3 pages will in and around take 60 seconds at most. Now you don't have, your client won't give you 1 minute to scrap 3 pages. Now what you have to do, you some people tell, hey, why not go with the multi-processing? But if you go with multi-processing, then your program might be fast, but not that fast enough, which you intend to have. Multi-threading can solve this problem to some extent. What do? You create a queue or this job, you divide this job into 5 or 6 parts. Let's say 3 parts. Okay, 3 process you create, P1, P2, and P3. Okay, each process is intended to complete or scrap 1 page at a time, and you simply tell the dispatcher Juggle or tell the interpreter to start the process and do whatever they want to do. So what you see, each process start at least they start the program, but at some point they stop. If I can draw a picture, then I can understand you most. I can tell you guys most like how it happens. Let's say process one, and then it's a process 2. Okay, and then it's a process 3. Okay, see, if I consider about the time frame, what you can see, this is like this time frame will take something around like 35 seconds. Now if I go with the previous manner, sequential manner, process 1 first 20 seconds, okay, then goes with process 2 second 20-second, which is the end of the 40th second, and then with the process 3, which is the end of the 1 minute. So this is how it works when you go for a sequential manner. But in here, at least just couple of seconds before or just couple of cycles before, your processor start the second process, and then again before ending of that, your processor start the third process. So this will save you actually some a couple of time, a couple of seconds. It will save you maybe 15 or maybe 10 seconds. So this is basically This is basically in code. The Python threading works. Now let's say you want key, if interpreter C, two objects are there, or two what I can say processes are there, and still one process is in the waiting, then interpreter obviously has to release the process one. That is when the barrier comes. Barrier simply create a pool or a container where interpreter push all the process before execution. If the interpreter is if the container is filled, then an exception occurs, which is called barrier broken exception. If the container is not filled, it's like the container can hold three, so now it is a one, then it's keep on pushing until the last process or the last thread hasn't finished, right? So this is how actually the barrier keeps you basically keeps you track of all the threads. Like if you want three threads to finished first, then again push another three thread, finish it, another three thread, finish it, like this manner. Use barrier. So for that, in order to use barrier, I will simply create a barrier, which is th dot barrier. Then I'll use let's say 5 threads. I want to I want to execute 5 threads at a time. Then I will use 5. Okay, so then let's see what is inside this B object. There are a couple of stuffs. Abort, broken, n waiting, parties, reset, wait. So if so first forget about this abort part. Later I will come at abort. Let's say B dot and go for broken. Okay, false means I have 5 threaded barrier now. So let's say how many threads we have currently. Th dot active count. We have only one thread. What is the name of that thread? This is actually the ID of that thread. So it is a main thread. All right. It is our main thread which is currently executing, because the console which you guys are watching right now, that is the main thread. Now next to it we have n waiting. N waiting means we have to see how many threads are waiting at the barrier. All threads must reach barrier, get executed, show the result. This is the way. So let's see, we have this barrier dot in waiting. Okay, we have 0 because I haven't created any thread right now which at least reach the barrier state. Now I'll create threads. I'll create threads and show you how it reach. But before that, you guys need to understand the logic and the concept at this join place. You create a thread, and that thread start executing but hasn't finished yet. But that thread consumes a whole lot of computer memory. Let's say you are writing a 2 GB text file, flat file. It will obviously consume a certain computer memory or computational power, I can say. So that thread will take some time, 2 minutes, 3 minutes, as per your processing power. 2 minutes, 3 minutes, maybe 5 minutes to complete. But when you start the thread, let's say you have 10 GB to process. Now you are creating 5 threads. Each will consume, or each will process 2 GB of data. Each 2 GB data thread need 10 minutes to complete. So 10 minutes is a bottleneck. So give or take, it will take like more than half an hour. I am taking assumption more than half an hour to complete the whole process, or maybe 20 minutes or something. I'm not going into that, but not in 10 minutes, obviously. So what happened? You start the first thread, and after starting and your barrier, let's say your barrier is three process barrier, three thread barrier. You start your first thread, it start executing, it went into the execution pool, and computer and processor is taking care of it. Okay. Next, your next process is already spawned by that time. Sorry, not process. Your next thread is spawned by that time, and again the next. So all the five threads are spawned. I'm not telling you it's executed. No, it's spawned only. So all of them will reach the barrier step first. Now the barrier is now the barrier program is like a person. He is looking, oh my god, I am asked to handle only three threads. Now I am getting a queue of five threads. Yep. Then that should be called the barrier broken error. Okay. At the moment barrier is broken, it will create an exception or for the dispatcher juggle of the OS and abort the process. This is how this whole concept called. Now let's say now how you use it, where you use it. Mostly in many server programs, the people who write server like Nginx or Apache or IIS, what they do now, they create their own payload delivery system. Now, in payload delivery system, when we call a server crash, the moment the throughput or the payload, maybe forget about the payload. So the throughput, first of all these servers, I'm talking about the event-based server, not the process-based. So when the throughput of every server per second crosses a particular threshold value, that moment server crash means the server stop responding. Means what is the meaning of server stop responding? That means that barrier object is broken. Now the program don't know whom to execute first. When a barrier is broken, it's like when a barrier is broken, all the people are simply running into the field. Now the police don't know whom to catch first. Similar like here, the barrier is broken, all the threads are passing into the field, and the computer don't know which thread to execute first. This is why barrier broken error occurs. Okay. Now after a barrier broken error finished, we have to reset the whole phase. That is what is called server reboot. Okay. Now many hackers are there who can remotely crash a server. Okay. When I get into another of our video, another of our discussion about all this, I'll clear it out in a more detailed manner, but not now. Okay. So these are the main stuffs about the barrier. Our next object is semaphore and mutex. See what is let me write a program on this stuff. Hold on. Where I create the stuff. Oh yeah, it's there. Okay, so as for the ID, guys, I prefer VI. If you guys can use Atom or all other than that. So first is first, what you have to do, you have to write the heading, which is obviously our Python world community. guys, whenever you write any program, whenever you, whatever you do, always try to write any help text or doc string about that. Okay. Okay, so this is our sample program, which is called execute. Then we will simply print the value q. Okay. Now, some people, there is a stuff I want to show. Let's say there is a list. Okay, th list. Acha, for coding practice, if your loop variable is not required at any place, do not use I, J, K, L, M, N, O, P. Okay, use underscore. This is the standard coding practice for Python. Okay, so next is ranges like that. Yeah, let's create a thread. Okay. Target is execute. Let's say, hey. Okay. Now, some people ask why in tutorial there is a extra comma or something like that. I said give it for a best practice. You can remove it or don't give it, doesn't matter. Okay. So Python world can get thanks. Yeah. Next, what I do, I'll simply write thx dot start. Now, what is the meaning of this line? Thx dot start. Now, thx is our thread. Okay. Now, I am asking interpreter to start the thread, but not to finish it. Nope. I'm not asking the interpreter to finish it. I'm asking it to start it only. Now, what is the difference among it? I already told at some point I am asking the interpreter to stop the thread until the previous one start, or to stop the thread according whatever you want. So I am simply when the execution will finish, that is totally depend on the interpreter, not me. But when the execution start, that depends on me. That is the difference here. Okay, now in order to do that, I need to do like thx.join. Okay, some people, I don't know why they do it. Okay, there is only a reason for doing that. If you want to do something on a running thread, let's say you want to fetch the current state of the running thread, then if it is alive, do something. If it is dead, do something. So if or if it is a binary semaphore, do something. If it is a mutex, do something. Or a bounded semaphore, do something. Only then, only and only then you need th.list.append and then thx. This people do, and then create another for loop and then start it, join it. Now there is another reason. If but those reasons only for when you are processing a huge program which might take you half an hour. Okay, so in that case, when you write thx.start and then you do thx.join and simply finish it up, then what happens? Thx thread that start, okay, and then it push into the queue. But when you but for that pushing, from one queue to another will take one or half computer cycle. If you don't want to lose them, don't do it. If you want to lose them, it's your choice. th underscore list dot append. No, I'm not going to do that. Those are, yeah. So it executes. So if I really want to understand the anatomy, what happens here? I create a thread object here. Now, and I start the thread object, I create a join. Then I tell the interpreter, wait until the execution happens. This is the meaning of this join, right? Now, there are many arguments. There are many arguments for a thread which has been created. Okay, I'll show. Let me open up my interpreter. Hold on, guys are there. Yeah. Which one? Yeah, this one. Okay, so yeah, I guess so. So yeah, let's import. Okay. Okay. th dot hello world x, no, th x equals to th. We don't need any args. Sorry for that. Okay. These are all the stuffs we can do. Now, a thread can be a run at the back end or at the background, or it can run at the front end. Those threads, let's say we have a job, we need to extract the data from a page or from a PDF. Then those data we need to mail to some guy. So there are two processes. First process is let's say there are two processes. First one is extracting the data from the PDF. There are plenty of modules for that. The second one is mailing that stuff to the guy, right? Now the mailing program or the mailing part that can execute at the back end. For that we don't need any foreground or any foregoing process intervention. No, a daemon process is enough for that. Now what is a daemon process? A daemon process is a process which computer or the executioner or the dispatcher Juggle gives the lowest weightage and push it into the wait list or push it into the backend list. Now the wait list or the backend list is something where programs with the lowest weightage resides. Those computer program, the computer executioner execute on a low priority basis at the background as a background stuff. Those are not prioritized because for them no one is going to wait, no program is going to have a lock or something. So we can create something like that. We can create a daemon thread, but for that we need to we need to give the daemon argument as true. Now what are the arguments available? If we want to do that, we need to have like help test, help th.thread. We have all these big help screen. Now in help screen I can see like, yeah, Yeah, you can see daemon equals to none. If I put daemon as yes or sorry or true, then what we do, it represents as a daemon thread. Now name, get name. Every thread must have given some name. Okay. So otherwise it will have a big identifier number like of stuff or a what I can a function response call. No. So give your thread a good name or don't give. That's your stuff. Args and qargs, those are like the variables for the particular thread. Like sorry, the parameters of the particular program which you want to pass. Now there's a way that you can you must do or you want to do. Hold on. Sorry. Yeah. For we have a ths is our first thread is daemon. Oh shit, it's ths. It's false because it's not a daemon. Now we can check, is this alive? Okay, is this alive using this? Yeah. Oh, it's depreciated warning. I forget about it. Sorry, guys. It's a depreciated warning. Nothing else. Yeah, it's dead because why it isn't alive because I haven't start or this. Okay. Now it's false. What to do? How to do? How to do? It's going to take some time. Now if I put a timer in x like time dot sleep for 5 seconds, then you might see that this dot is alive is true. Okay, so ths dot get name. What is get name? It will give you the name of the thread. For us it is thread 1 because I haven't given any name to that. So let's create a program. Okay, let's create a global variable. And guys, my time is actually a bit of bound, so this stuff which I'm telling now, which is lock, will be last for today. And tomorrow on our next session we'll continue again on various topics on threading. And threading is a very interesting topic. And I am a very detailed person, so if I tell you guys something, then I will tell you in very detail, so that at any place you any of you don't feel anything which you need more, right? So there are innumerable stuff, believe me. Nobody cares about it, but subclass hook, para hook, post hook, string hook, thread hook, and sub hooking, these are innumerable concept, and I will share all of it with you guys. Okay, but now time bound manner, one at a day. Today we learned how os react or how things execute in os. Tomorrow we will learn semaphore and mutex. Those are very important for trading.
Kaushik,
Ah,
hello.
yeah, bro.
I had a doubt.
Yeah, tell me, bro.
That like we can see that there's a function. We are making functions. Okay, there.
Huh.
But what if my
Huh.
function want to return something?
Ah, fantastic questions. Yeah, for that we use local objects. Okay, for that we use local objects or event managers. That I will discuss, bro. I'll come one to one.
Okay, okay,
There is this thing called thread.local. I'll tell how local objects work.
okay,
Now,
okay.
there is a thing. Let's say we have a global object. Okay, you want to see how many globals are there. You simply do like, oh shit. We can do it like here, right? Oh. Yeah, this is the globals function. Now what is a globals function? Globals function will tell you on an interpreter console how many global objects are lurking here and there. Okay, now finally let's create a variable var world var equals to, let's say, 10. Okay, now I will create a program, let's say def xx. Okay, and inside them I global world underscore var. This is how you access a global variable. Then what we do, world underscore var equals to 100, right? And then what we do, simply write a print finished. Fantastic, we did it. Okay, so let's do it, let's call it finished. Now check world var 100. Now think, we have one program to do it, right? Let's say there are three programs which basically takes this world var object and operates on it. Let me show you. Def add underscore x, simply like this, world underscore var equals to world underscore var plus, let's say, 100. Okay, and def let's say minus x. Okay, world underscore var equals to world underscore var minus 70. Now you create a threading a thread stuff like this, for underscore in range 5. Okay, t1 equals to th dot thread. We have add. Oh shit, biggest mistake I did. Oh, God, sorry, I made a mistake. Okay, let's create the second thread. Okay, minus a, yeah, and next start it. Okay, t1 dot join, t2 dot join. What happened? Assert group is. Oof. Oh, I forgot to print it, right? Now, anyone can tell.
Hi.
Hi.
Hello. Can I ask a question? Am I audible?
Yeah, yeah, you are audible. Yeah, tell me. Tell me, bro.
Okay. Which editor are you using? Is it Vim?
Yes.
And what is the
Yes.
difference between V and Vim? What is the difference between VI and VIM?
See, mostly in Linux, Vim. What I know, ki Vim is not just like an extension to VI. VI is something invented by the. You heard about Fedora, right?
Oh,
Fedora and
Fedora.
I'm not
Yes, yes. Yeah. Huh.
Fedora, Ubuntu. Those are two different flavors. Okay.
Distributions.
Uh,
Yes, yes. I am using Ubuntu. Yes, currently.
yes. So in Ubuntu, if we go, we can see we mostly we have all this Vim. If you go to
Yes,
Fedora,
yes.
I have another. I can show you, but that's another laptop. I have Fedora and Kali. Those are different flavors. Don't distribution flavors. Distribution and flavors. Those are technically different. Those are different
So what is the
flavors.
flavor? What is the flavor?
Good question. Mac is a Linux. Android is a Linux. Do you know?
Yes, yes. That I
Mac.
know.
Hmm. Now, why they call it Mac? Why Andy Rubin named this at Android? The even
Why?
Linux is also not Linux. Linux is something which Linus Torvald, the genius, he get this stuff from a open source activity from Unix. Unix is the mother thread. Okay, if you know Unix, all the kernel stuff, then the layer stuff, the localization stuff, the delocalization stuff, everything Linux inherit from Unix. Okay. Then it start evolve. Everyone create a fork or a branch of themselves. Someone create a genome, and there is a KDE. Those are desktop environments, and there is someone create Nautilus. Okay, Nautilus is one of my favorite, and suddenly one of some of previous days they create a BSD. BSD is a flavor. Why we call it flavor, not distribution? Distribution is where we can have a significant difference between two branch. Okay, now there is a now I can say there is a debate among them. The Mac people or the Mac creator, they never admit in an open forum ki they really copy it from Linux. But we all know ki BSD and all those stuff, they are really a great copy of Linux. Nothing more than that. If you went into Mac, you might get confused with their look and feel, but in reality, in inside, everything, the processing, see, every operating system now there is a way of communicates among layers, right? You know, there are multi layers. These are all multi layer operating system. These are not the 1990s. Here we have a kernel layer, and there is a driver layer. Then there is a storage layer, or what we call where all the folders and files or the magnetic tapes resides, right? So these are all multi-layer operating system. Now there is a communicating system among them, like how because kernel is the heart, so you need kernel to work, right? Otherwise your laptop or desktop won't respond. Now how they communicate, that's what make a distribution. Kali, Fedora, they communicate the same way Linux, Unix used to communicate. But Unix is a kind of evolving, so they're trying to change the way of communicating with kernel or something. Now I don't know how much Mr. Linus Torvald they or his foundation had successful event on that, but I hope later because Ubuntu will evolve more and they will change the way kernel communicate to others. Now, any one of you, I don't know, any one of you are from Java background. Do you guys have any idea how currently in Spring they have a concept called data subscription and continuous data flow? Any one of you have any idea like that?
No.
Continuous data flow, think like that. You have a gas pipeline or you have a oil pipeline running at your home, correct? And you have a oil pipeline running, and if you pay the bills to Mr. Ambani, then he will let you use that particular pipeline. It's called of a subscription. Okay. Kernel is similar like that. They are adapting to this concept. Okay, let the communication bridge remain open. Remain open for you open your laptop. Okay, kernel starts communicating to all the layers. Okay, communicating means one-way communication. One way, not the two-way. One-way means create a bridge. Simply create a bridge to a particular folder. Okay. Now, if you click on a folder, then the response simply start flow through that particular bridge and going to kernel. Now, kernel decide what to do with that. Okay. Now, there are several more steps between them, passing through a device manager, drivers, these, that, and all that. But I'm passing through with them. I'm not telling about all this because it will make you confused. Now, what that do, that driver manager or the stuff, that's something that send the signal to the kernel. Now whatever you want to do, you want to delete that stuff, you want to edit it, kernel will respond the signal according to it. Now this will reduce the time, because if there is a bridge is open through which the signal is passing, then there is no need to open the bridge, and that will consume a time. If the bridge is already open, then it simply flows. All right. So this is how Unix system currently communicate, or rather Ubuntu communicate currently. Now same thing they follow our what is called Fedora and Mac. Now Mac never admit, but they follow it. What makes a different distribution? When people say it a distribution, what makes it different? When there is a difference, or when there is a change in this process communication or inter-process communication, rather IPC. When there is a change in IPC, then that is a different distribution, like Nautilus. Nautilus is really a different distribution. Now, see, bro, there is a debate about it. Some people admit, some don't. And I don't give it a shit. What Mac people admit it not. Their system is pretty a copy of Linux. Android is a Linux copy. So there is no debate around that. But Mac people never ever they admit that is a Linux copy. But yeah, you use Ubuntu, right? Which version? 1804 or 2004?
2004.
Why 2004? Why migrate to 2004?
I don't know. Just I started this year only. I started from this 2020 only.
Bro,
just a few months back.
The beauty of Linux is, the best beauty of Linux is it doesn't require any kind of like medicine like what Windows need. If you are using Windows, shittiest operating system I ever seen in my life, you need antivirus, you need this, you need that, you need this, and you need that.
But Windows is actually much slower. After installing Linux, the laptop actually become faster actually.
Yeah, it depends. It depends on something like Windows. If you are really using Windows on, let's say C# type of programming, then Windows is super fast. But if you are really trying some data science stuff or something like that on Windows, it sucks. For that purpose, where there is a IPC related stuff involved, like sending a file, copying a file, reading it, okay, splitting an object, something like that, then Linux should be your first choice. So
I was not talking about programming. I was actually talking about the normal usage. Actually this laptop is very old one, about 7 years old. So the Windows one, when it was Windows, so it used to hang very often.
No, because Windows is heavy.
It actually used to. Yes, exactly. But after installing Ubuntu, it actually become much smoother. It does not hang that often. Sometimes, rarely it hangs, but generally it does not hang.
Yes, because Ubuntu seldom hangs because of this stuff like Ubuntu doesn't have that much of graphical user interface. Nowadays they have, but when I start programming, we used to